1. All right, here we go. One says, suppose that a particle moves along a straight line with the acceleration defined by, that's weird, t minus 5/2, where t is in the interval 0 to 8. Find the velocity function and the displacement function. Also find the total distance traveled over the time interval 0 to 8. Okay, how do you find the velocity? Antiderivative of acceleration. So antiderivative of t minus 5/2, which is
t squared over 2
t squared over 2 minus
5 over 2.
5 over 2t plus c. Yeah, how am I going to find that c?
Where it says, yeah, 0.
Velocity at time 0 is 3. So 3 equals c. 0 minus 0 plus c. So c equals 3. Okay, so my velocity function is t squared over 2 minus 5/2 t plus 3. Okay, how do I get the distance? Antiderivative of velocity. Distance is the antiderivative of this thing. Which is add 1 to the power t cubed over 6 minus 5t squared over 4 plus 3t plus c. Okay, now I got to find this c. And to find this c, I'm going to use the fact that the distance at time 0 is 0. Oh, that's easy. So what's that c going to be? 0. Yeah, he's going to be 0. 0 equals 0 minus 0 plus 0 plus c. C equals 0. So distance is the t cubed over 6 minus 5t squared over 4 plus 3t plus 0. Okay, part C says, find the total distance traveled over the interval 0 to 8. Remember that when I find an antiderivative, it gives me two different things. It gives me the displacement, and I can find the total distance traveled. Do you remember the difference between the two pieces?
Displacement. One of them depends on if you go back and forth, and one of them only depends on the distance.
Yes.
The total distance depends on distance, and displacement depends on where you ended up and where you started from.
Correct. Displacement says I started here, I ended here. How far did I go? Right? Displacement just is a picture at the beginning, a picture at the end. How far did I go? If we integrate from 0 to 8 of the original function, of the velocity function, it's going to give us displacement. If I want the total distance traveled, meaning go back and forth and count how many steps, then I integrate from 0 to 8 of what?
Distance.
Absolute value.
Absolute value. Because remember, the velocity function could be positive and negative. When it's positive, I'm moving forward. When it's negative, I'm moving backwards. When the velocity function is positive or negative, the displacement is going to be just a tiny bit, right? If I want the total distance, then I take away that negative part and say I always want to be moving forward. So I use absolute value to take away that negative part. So to find the total distance traveled, total distance, you integrate the absolute value of the velocity function. So I'm going to integrate from 0 to 8 the absolute value of that velocity function, which was t squared over 2 minus 5/2 t plus 3. And I'm going to just put that in decimals. Put those absolute value bars around it. Let me do it. I'll do it once today. Oh my gosh, share different things though. This
For
one.
number 1, what I did is I just plugged it into the distance equation. I just plugged 10 into the distance equation.
Uh-huh.
That works too, right?
Yeah, can you take the final distance minus the initial distance?
That gives you the displacement. As long as the velocity is always positive, then that'll work. But if you had a negative velocity, that won't work. Yeah, because that gives you displacement.
So still, if we're trying to find coefficients, we should use absolute value of the velocity.
Yeah, I think so. I got 29.5. Some units, it probably tells me the units, meters. Okay, 2. A car traveling 44 feet per second. Ooh, okay, what is 44 feet per second?
Velocity.
The velocity, right? At time 0, right? We're counting this as like time 0. So the velocity at time 0 is 44. Decelerates at a constant 6 feet per second per second. What does that tell me about the acceleration? -6. Yeah, mine was 6. Yep. How many feet does the car travel before coming to a complete stop? When does the car stop? Stops when the velocity is 0. Okay, if I have the acceleration, how do I get the velocity? Antiderivative. Okay, so V of t is the antiderivative of this guy. -6t plus c. How am I going to find c? Yeah, use that at time 0, the velocity was 44. So 44 is -6 times 0 plus c. C equals 44. Okay, so my velocity function is -6t plus 44. The car stops when the velocity equals 0. So 0 equals -6t plus 44. Subtract 44. Divide by -6. 22 over 3. I don't know what that is. 7. Let's just leave it at 22 over 3. 22 over 3 somethings like seconds or something. Seconds.
Like 0.
Because it told me that's how fast I was going, like a car's traveling at 44 feet per second. I'm just assuming that like that's my starting time. I'm starting like right now, where like boom, they told me this, that's where I start. Okay, so it says how many feet does the car travel before coming to a complete stop? How many feet does the car travel before coming to a complete stop? So it starts at time 0 and it ends when? When the velocity is 0. That was like 22 over 3, right? If I want to find out how far I went, what can I do? All right, put that into the distance formula. Sure. Okay, how do I find the distance formula? Antiderivative of the velocity. Okay, -6 t squared over 2 plus 44t plus c. Whoops, that's a distance there. D. How am I going to find that c? So remember, I'm just assuming that like this is my starting point. Boom, right? Like I start right here. I'm going to call this 0. So I'm just going to say my position is 0 and my time is 0 right now when I start at going 44 seconds, decelerating at 6 feet per second squared, right? So if my distance at the beginning is 0, then this constant here, I'm just going to make it 0. So I'm just going to use this distance formula. Whoops. D of t is -6 t squared over 2 plus 44t. So I'm going to say my distance at time 0 is 0. Wherever I am, that's my starting like marker. I start at this marker. I know how fast I'm going. I haven't gone anywhere yet. And I know what my acceleration is for my deceleration. Okay, so if I want to find the total distance traveled, I take the time, which was 22 over 3 seconds, and I plug it into the distance formula for t. I can only do this because it's doing the same thing the whole time, right? Like it's always going forward. It's not going backwards at all. The velocity is never negative. Otherwise, I might need an absolute value, but this guy's always going forward. So d of 22 over 3 is negative 6 over 2 times 22 over 3 squared plus 44 times 22 over 3. Someone's got to put that in the calculator. That one's too hard for me to do in my head.
One 61.3.
Okay. 161.3. I don't know how many decimals they usually want you to have, so, you know, keep some and go with it. Feet. Feet. So I found the velocity function first by integrating. I found the distance function again by integrating. I found out when the velocity was 0 by taking that velocity function, setting it equal to 0. I used that time to see how far I went before I stopped. I use a lot of pieces there. Okay, 3. This is 3, even though you can't see the number on the screenshot. A stone thrown upward from the top of an 80-foot cliff at 152 feet per second. What do these two things tell you about the stone? What do those two things tell you about the stone? The what?
Current position.
Current position. So let's call it initial, right? Because that may as well be the current. The initial position and the initial velocity. Yeah, 152 feet per second. So my position initially is 80. My velocity initially is 152. Okay, eventually falls to the beach. For this problem, take the acceleration due to gravity to be negative 32 feet per second squared. How long does it take the stone to reach its highest point? What is the maximum height? How long before the stone hits the beach? What is the velocity of the stone on impact? What do you think you're going to do to solve this question? Antiderivatives, right? If you take the antiderivative of acceleration, you're going to get velocity. Yeah. Then you'll solve for c. Then you're going to take the antiderivative of velocity to get position. These first 3 questions ask you about the position of this stone, right? If you have an equation for position and you want to find the maximum, graph it and find the vertex. Yeah. If you have an equation for position, so this is when does it reach the maximum height and what is the maximum height? This one will be the x value of the vertex. This one will be the y value of the vertex. If you want to know when it hits the beach, the stone goes up, it comes back down, it hits the ground. That's when the position is equal to 0. So you'll take your position equation and you'll equal it to 0. Okay, let's talk about this last one. How are we going to do part D? What is the velocity of the stone on impact? How are you going to do this? So you're going to find when it hits the ground.
Find the t when it hit the ground. T value.
Yep. Plug that into the velocity equation. So A, B, and C, you all solve with the position function. A and B is the vertex of the position. C is the x-intercept, or when it hits the ground. D, once you know when it hits the ground, you can plug that into your velocity equation. Do I need to do it, or you guys are confident you can do it? I'm confident you can do it. I don't know if my belief in you is enough for you to have belief in yourself. You try it. If we need to do it at the end, we'll come back to it. Okay, 9. Sketch the region between y equals x squared plus x minus 2 and the x-axis over the interval -6 to 3. Find the area of the region. Okay, sketch the region. I'm going to use Desmos. And then find the area. How do you find the area? An integral, right? Yeah, an antiderivative, a definite integral in this case. Okay, let's go to Desmos. This one. X. Oh dear God. Okay, y equals x squared plus x minus 2. The x-axis, y equals 0 if you want to, and -6 to 3. So I'm going to put in x equals -6 and x equals 3 so I can see where it starts and where it ends. Okay, I have to zoom out a little bit more. Okay, so I'm looking for the area in this region between the green curve and the x-axis. What I want you to notice is that over here at the left, the green curve is on the top and the x-axis is on the bottom until this x value right here, until this x value right there, until x equals -2, right? At -2, what happens? The green curve hops below the x-axis. So now between -2 and that x value, which looks to be about 1, the x-axis is on the top and the green curve is on the bottom. Then from 1 until 3, the green curve comes back to the top and the purple curve, the x-axis, is on the bottom. So if I want to find this area, how many integrals do I need?
3.
3. I need 1 for this part over here from -6 to -2, where x squared plus x minus 2 is on the top minus 0 on the bottom. Then I need 1 from -2 to 1, where 0 is on the top minus the green curve, x squared plus x minus 2 is on the bottom. Then I need 1 more from 1 to 3, where the green curve is back on the top and the x-axis is on the bottom.
Why can't you do an absolute value for this one? One integral with an absolute value?
That will work for this one. It won't work if you're, if it's not 0. Yeah, so if this purple function was something else, then I can't, but because this purple function is just the x-axis 0, then you could just make absolute value. But if it wasn't, it wouldn't work. I wanted this one, new. I'm gonna snip it in there. That. Here. Oh dear Lord. Super huge. Okay, area number 1 is this one. Area number 2 is this one. I'm sharing the wrong screen. And area number 3 is this one. So I'm going to set up 3 integrals. 1 from -6 to -2, plus 1 from -2 to 1, plus 1 from 1 to 3. Okay. This guy is going to be the green one. This guy is going to be the yellow one. And this guy is going to be the pink one. Okay, in the pink one, the function x squared plus x minus 2 is on the top and 0 is on the bottom. Is that the right function? Yes. In the yellow one, 0 is on the top and x squared plus x minus 2 is on the bottom. In the green one, the x squared plus x minus 2 is back on the top and 0 is on the bottom. You're gonna put those three things in Desmos. You're gonna put parentheses exactly where we have parentheses, and you're gonna add up your areas. They should all be positive when you put them in Desmos. If you want the x-axis to turn out to be a color, like an actual line, then graph y equals 0, because then you'll be able to click and find things. Good? Do you need 8 as well, or is that okay? That's okay.
Can we actually do 3?
Yeah, we can go back to 3. Okay, 11. Find the area of the shaded region below. Okay, in this one, the function on top is always the same, and the bottom function is always the same, right? It doesn't change, so I can just do one integral. I only want the yellow area, so where am I going to integrate from? Starting at x equals 0, ending at x equals 2. And I do top, square root of x plus 2, minus bottom, 1 over x plus 1 dx. You can do this one in Desmos, but it's keep a lot of decimal places. Because the problem is like, if you're going to integrate this guy by hand, this last piece is going to turn into a natural log, right? Because it's 1 over u. So if I was going to integrate this by hand, it would be a natural log. So the actual answer has a natural log in it, which is like a non-repeating, non-terminating decimal often. So if you're going to integrate this in Desmos, just keep like 6 or 7 decimal places when you type it in to infinity, and then you should be able to get it correct.
It worked when I used 3 decimal places.
Matthew says you can just use 3. I don't know. Someone this morning tried 2 and it did not work. So apparently it's somewhere between 2 and 3. 2.5 decimal places, yeah. Okay. 15. Find the area of this region. Yeah, turn your head, but turn your head this way. Always turn your head this way. Yeah, so turn your head, because if you turn your head and you draw your lines horizontally, then the red function is on the top or on the right, and the blue function is on the bottom. If you turn your head, what variable are you using when you find your antiderivative? Y. So we're going to turn our head and we're going to do an integral with y. So we're going to go this way and we're going to do a dy. That means these numbers on the integral need to be y values, right? The small y value is -1. The big y value is +1. So I'm going to integrate from -1 to +1. When I do dy, I do right minus left. So the right function is the red one, e to the y, minus the left function, y squared minus 2. Notice that I put that second function, y squared minus 2, in parentheses, because I have to minus both parts of it, right? So it's going to be minus y squared plus 2. But if you type it in like that to Desmos with your parentheses, he should work out.
For this one, could you just replace all the x's with y's and all the y's with x's and then just solve? And then at the end, if you do need an equation, just replace the x's back with y's.
Sure. You just have to remember that this one is the top guy and that one's the bottom guy. I think if you replace them, it should work. Yeah. This was the last one. 15. Okay, I'm going back up to 3. Here he comes. Where is he? Here he is. Okay. So we said to find A, B, and C, you need to have which equation? The position. Okay, I've got acceleration. How do I get position? Take the antiderivative 2 times. The first antiderivative is going to give you velocity. The second antiderivative is going to give you position. So I'm going to start with acceleration. I'm going to take the antiderivative 2 times. Velocity is the antiderivative of acceleration, which is -32t plus c. Okay, we knew that the velocity when we started at time 0 was 152. So that's going to tell us that c is 152 in this case, right? 152 is negative 32 times 0 plus c. C is 152. So velocity is negative 32t plus 152. Position is the antiderivative of velocity. Negative 32 t squared over 2 plus 152t plus c. I got to do another c. The position initially is 80. So when I plug 0 into this position equation, I get 80 out. I can do negative 32 over 2. It's negative 16, 0 squared, plus 152 times 0 plus c. So c is 80. Okay, so my position function is negative 16t squared plus 152t plus 80. Yeah? Okay, part A and part B said, when does it reach the maximum height and what is the maximum height? So to solve that, I need to know what the picture of this function looks like, and I'm looking for what? The vertex, the maximum. So I'm going to graph this guy in Desmos, and I'm going to try to find the vertex. Position equals negative 16x squared plus 152x plus 80. Okay, I need to zoom like way out. So let me see. My x-axis, I don't have any negative positions, so I'm going to make this guy like 0. And then it looks like it hits the ground pretty fast. So let me make this guy like 15. My y-axis, again, I don't have negative height. So let me make that guy 0, but it looks like he's going pretty high in the air, right? Like if he starts 80 feet in the air, he's going to go pretty high. How many? 200? Is that enough? Nope.
It's like 445.
500 it is. Okay. So there is my rock. Yeah. Let me zoom out a little tiny bit more. There's my rock. He starts here at 80. This is like the building right here at 80. He goes up. He reaches his maximum, he comes back down, he hits the ground over here, right? I need this point up here, 4.75, 441. And I need this point over here, 10, 0. This point up here is my maximum, and the 4.75 represents the time. So after 4.75 seconds, the height is 441 feet. Yeah. This point over here says after 10 seconds, it hits the ground, right? Is it a rock? I don't know what they're doing. It's a rock and a cliff and a beach. The rock hits the ground. Yeah. So 4.75 seconds, it hits a maximum height of 441 feet. After 10 seconds, it hits the ground on the beach. So let's go back. I can't. Yes, I can. This is like my 42nd day of class and I still cannot do it. It's fine. Okay, I drew this graph. It looked like this. This was 4.75, 441, and this was 10, 0. So at 4.75 seconds, it reaches a max height of 441 feet. I'm making those units up. Is that what it was? Yes, seconds and feet. Okay. At 10 seconds, it hits the ground. So up here, how long does it take to reach its highest point? 4.75. Probably S is for seconds, right? I don't know. You click that little button. What is its maximum height? 441, probably FT. I don't know. How long before it hits the beach? 10 seconds. What is the velocity of the stone on impact? How do we say we're going to solve this? We're going to plug 10 into the velocity function. Here was my velocity function here. I'm going to plug 10 into that guy for t. So v of 10 is negative 32 times 10 plus 152. 20. What are the units on velocity?
Feet per second.
Feet per second. Other questions? Yeah. Yeah.
How did you get that 20 feet per second? Because it's that negative 32 times 10.
That's
plus
negative
1.
320. I did made it negative 132, which is clearly wrong. What do you get?
I got
Negative
52. Yeah, negative 168.
168. Clearly, the velocity is negative because it's going towards the ground. See, never rely on my calculator. You have a homework assignment due tonight. You have one more handwritten quiz on Monday. The final exam review has been posted. It's due the same day as your final exam that night. I would suggest you do it before you take your final because it would be dumb if you didn't. But you make your own choices. So you can do that or not. The final exam is next Friday. It begins at 11 a.m. From 11 to 12, you have to do the grade scope portion. From 12 to 1:30, the Edfinity portion. The Edfinity portion actually opens at 11:30. If you finish the grade scope portion early, you can start the Edfinity portion at 11:30. It doesn't give you extra time though. You still only get 90 minutes. So the grade scope portion is 1 hour long from 11 until 12. The Edfinity portion is 90 minutes long from 12 to 1:30. If you finish the grade scope portion a tiny bit early, you can start the Edfinity portion early, but it will still stop you after your 90 minutes, okay? Yeah.
What day was it again?
Friday,
Friday.
next Friday, the 19th.
Is there anywhere where you have this written down orange?
Yes, it is written. The announcement will post in an hour. Okay. All right, let me stop the
Monday's gonna be,
Monday. Yeah, Monday I will answer any questions you want from the final exam review. Yep.